The bigger play associated with the SD-WAN market is the introduction of AIOps, or AI-driven operations, into the WAN equation. Hi everybody, my name is Jeff Aaron, and I'm VP of Enterprise Marketing here at Juniper. And I'm going to spend the next 10 minutes or so talking about a really exciting transition that's happening from the traditional WAN routing world through the SD-WAN model of delivering WAN services to this new exciting way of delivering WAN services that we call the AI-driven WAN, which is part of the AI-driven enterprise. To understand where we're going, it's worthwhile to first take a step back and understand where we've been. Anyone who's ever dealt with the wide area networks know that it's a fairly complicated infrastructure to try to deliver a high value service and also to troubleshoot, right? There's lots of things that can go wrong that can actually adversely impact users across a wide area network. Whether it's availability, is the WAN link up? Is it down? Are there hardware device failures? Is there just an unplugged, bad cable or a bad port that can cause your WAN to go up or down or have degraded service? Is it quality, right? Is it latency? Is it jitter? Or is it packet loss on things like the internet that can impact your user experience over the wide area network? Or is it something like capacity, which is the one that most people think of, which is your bandwidth or the number of WAN links that are deployed to support your users and your application traffic? The fact of the matter is, any or all of these can come together to adversely impact your user experience over the wide area network. Now, SD-WAN, software-defined WANs, have emerged, or really emerged over the last decade, over the last 10 years, to help address these problems. Now, the beauty here is what they do is they try to take policies and how to redirect in terms of how to handle wide area network and application traffic to help route around things like failures and how to help guarantee things like quality of service to help deliver the best possible experience. The issue, though, is that SD-WAN has a lot of technical inherent limitations. For one is they normally are based on static policies. They're not dynamic. They're not done in real time. Secondly, a lot of those policies are done at the tunnel level. So they're based on multiple types of users and applications bundled together. They don't have visibility down to the actual user, the individual user experience or the session. And third, oftentimes they lack scale. Especially if you want to set up a point-to-point network where different sites are looking to connect to one another as well as to the internet or the cloud, it can become difficult to set up all those many tunnels and manage all that bandwidth and overhead that's going across that. And in fact, this is one of the reasons why SD-WAN hasn't quite taken off as fast. While it has been fast, it still hasn't taken off quite as fast as maybe some pundits would have predicted. In fact, it's only about a third penetrated to the total TAM today. And to be honest, SD-WAN's been around for over a decade. I was at a company over 10 years ago that first started pitching SD-WAN solutions. So it certainly isn't new. So some of the things that are being done to address this, first and foremost, is for SD-WAN itself, the architectures themselves are actually being blown up to help provide more scale, more lower latency, and better user visibility. So when you replace things like a tunnel architecture with something like session smart routing, right out of the gate, you can see some of the benefits today where you can go from the old SD-WAN model, which is very network-centric, to one that's more user-centric, more focused on individual sessions, and more has the ability to scale without having to use tunnels. So right out of the gate, this is one area where Juniper is excited because already we're starting to see the transformation from traditional WAN routers to first generation SD-WAN, which as we said is built on static policies and very network centric, to second generation SD-WAN, which is all about real-time traffic, low latency traffic, a tunnelless architecture which eliminates overhead, and it's all about enabling better scale. So that transition exists and it's happening right now. But playing the long game here, the bigger play associated with the SD-WAN market is the introduction of AIOps, or AI-driven operations, into the WAN equation. This is exciting because it helps on multiple fronts. One is it helps on day zero, day one. Things like automated deployment, templatized configurations, the elimination of fat fingering and human errors that can happen when you are deploying a wide area network or SD-WAN across multiple sites. Out of the get-go, by using things like machine learning and APIs and scripting, you can help eliminate a lot of those issues. But going beyond this, going from day 2 to the rest of the lifecycle in SD-WAN, that's where AIOps gets really interesting. The ability to do things like service levels, so you can monitor in real time with every individual user what's happening across their network and the applications and adapt the WAN as it makes sense, right? You can do things like anomaly detection to determine if things are trending in a bad direction and fix them before the users even know they exist. You do things like AI-driven support. So again, if someone's having a bad WAN issue, again, you can auto-correct that before they even know there's a problem. This is what AIOps is. This is what the AI-driven network does. And this is actually what Juniper is leading in terms of the equation and leading this transition. So what's interesting is when you start to bring AIOps into the WAN, two things start to happen. One, you're starting to see the world move from WAN routing to SD-WAN network-centric to SD-WAN user-centric to something that's more AI-driven in real time. So the WAN is transgressing. But secondly, you can start to see that this WAN is now being brought into an AI engine. It can actually now work across all the other silos. So this information on the WAN side can actually now be correlated with information on the wired domain, from the wireless domain, even on the data center and the cloud from the server storage domain to create a true end-to-end picture. So for the first time, you can actually do end-to-end SLAs to monitor user experience across the LAN, the WAN, the WLAN from client to cloud. You can do end-to-end troubleshooting. So if something goes wrong, you can figure out, was it a WAN issue or was it a wireless issue? And how can I go correct that? In fact, let's take a perfect example of this, right? You have, in today's, COVID environment, many companies overnight saw thousands or tens of thousands of new branch offices, pop up in that people are now working from home. Maybe you call them mini branch offices, but the issue is the same. You now have many, many more remote workers that need to have safe and reliable access to the network. But what happens if, let's say I'm on a Zoom call and all of a sudden my network goes down? And I call the IT desk and I complain, hey, my Zoom's down, my network sucks. Well, let me ask you a question. Let's walk through the IT. What could have caused that problem? Was it my client device? Was my Mac, the Zoom client on my Mac, did that break? Or maybe my Mac itself was having a radio issue and couldn't connect to the Wi-Fi. Or maybe it was my access point downstairs. Maybe that was the issue that was causing it. It was the Wi-Fi network. Or maybe it was the plug from my Wi-Fi router to my WAN router, to my internet gateway. Maybe that went bad, a bad cable. It happens. Or maybe it was Comcast. Maybe it was my internet service that went down. Or maybe it was Zoom servers in the cloud. Maybe they went down. Literally, there's anywhere across that whole domain where that problem could have occurred. And unless you have the ability to take in data from every one of those ingress points and correlate that using machine learning and use artificial intelligence to detect any problems, to help resolve those problems into self-driving mode, you're missing a big piece of the equation. So that's why we at Juniper are so excited about this transition. It's not just about moving the WAN into the next generation of a user-centric model. It's about client to cloud, combining the WAN with the LAN, with the WAN, and the data center all together under a common cloud and common AI engine. And guess what? That also includes security. So now you can bring security and networking together in the cloud running AI. So this is really the promise of things like SASE, but again, we're taking that one step further with AI-driven automated services, both for security and for networking. So this is the true fundamental shift that Juniper Mist is seeing, and it's all about transitioning to the new AI-driven enterprise, where all of a sudden you get better automation, you get better insight into specific user experiences, you get better assurance in terms of end-to-end SLEs across the LAN, WAN, and data center. And then you get better actions, self-driving actions where the network can correct itself so it's always optimized and problems are fixed before users even know they exist. So that's where the world's going. That's where Juniper is leading it. And we're excited about where we're going. So if anyone wants to learn more about where the Juniper Mist solution is going with respect to the new AI-driven WAN, please visit our website at www.juniper.net.